for those who don't know, we are a team using a deep learning model called Clip to essentially segment videos. So you take a video, describe what you want from it, and it'll just find like the best part using some deep learning algorithms that I've helped develop and create. So I'm gonna share a slide deck very quickly. Can everyone see my screen here?
Yes.
Perfect, great. Okay, so we'll get started. So hi, we're Video Clip. Everyone here was helped involved in creating this product. You guys want to unmute yourself, say hi, everyone. I don't know, Bhavya, John, Jungwoo, etc. Go ahead.
Hi, I'm Anvita.
Hi, I'm Pavia. I work mainly on backend for this project.
Hi, I'm Pinyao. I work mostly on front end.
Hi, I'm John. I worked with the backend as well.
Hi, I'm John Woo. I worked a lot in the backend while helping out in the front end as well.
So yeah, I guess we can start this presentation off. So what are we doing here? Video Clip is basically a service right now where you can go on a site, you can upload a video, type in a query, and tell me how long of a segment do you want, click submit, and then what will happen is this model that we've deployed will essentially look at your video, analyze the content of all your frames, and kind of match them just purely semantically to the text information, right? So like in a YouTube search, for example, if you're looking for a video, it'll match it based off text descriptions to the video or the title or the channel that uploaded. This is using technology that only looks at just the pure frame content. So it's almost like a challenge, but it works really well, surprisingly, and it's able to it has a very deep understanding of the rich connection between kind of frame content and text content, which makes it very useful and very general. That way you don't have to label the content of your videos. You can just upload something and find, in theory, any general level prompt. And so, Pingy, I want to go over some of our best practices.
Yep. So I'll be going over the best practices that we use. First, we started out with just our tutorials because we use the tech stack that's pretty unfamiliar to all of us. And next we did some basic planning. Here's a flow chart that Daniel and Jackson made. And we pretty much followed this to develop our app. And we had some trouble at first with the code because it was really unfamiliar for us, but we figured it out in the end with actual coding it and putting it on GitHub, the organization and everything. And then we had it all come together in the end.
Yeah, for sure. So I guess also just to cover a few more points, some challenges that came up, obviously were we were using a decoupled front end back end, which was unfamiliar to a lot of people on the team, but a great learning experience. Also interacting with some of the PyTorch code that I wrote to actually use the model. It's very unfamiliar to some people. So challenges there, but so I think some of the best practices were actually trying out a new tech stack and actually overcoming it to actually deploy something properly. And yeah, so John, you want to go over super basic user flow?
Yeah, sure. So the first thing a user will do when they get onto the website is to upload the video which they want to segment a clip from, and then all they have to do is to input a prompt which describes the clip and then the length of the clip that they want. And when they submit that, then the algorithm will find the most relevant segment and return it.
All right, and Anvita, you want to talk about some of the roadblocks we faced?
Yeah, so we faced a lot of roadblocks throughout the project, but we have overcome a good amount of them. So some of the roadblocks were working with a decoupled front end and back end, running inference on large models at scale. We had a lot of memory issues, which made the algorithm run pretty slow. And then developing efficient algorithms to create the video edits, and also working around React because it was kind of hard to figure out how to start off with it.
Yeah. So it's one thing, to develop a machine learning model on your local machine where you're not constrained by money in terms of hosting costs. But when you actually have to deploy something, you have to get really creative with how do you best use the limited RAM and processors available to you. All very tough roadblocks, which we inevitably overcame. And I guess that now culminates in a live demo of the product in action. So if you guys visit this website, I don't do it yet. Let me do the demo first because we're still working around some memory usage. Like if it overloads the site, it will break and nothing will work. So here I've uploaded a video. It's random. I found it on my computer. I think it's from a random text video data set. I don't really know why there is this video on my computer, but it's been a good one to test because there's lots of different scenes. Like here, there's people high-fiving. Here, there's people talking in front of something. There's here, like people drawing on a whiteboard, right? So if I wanted to just segment the part with the whiteboard, I could just say drawing on a whiteboard, give me 2 seconds and click the submit button. And now we're in queue. And so the model is currently running. One other challenge we faced was when 2 people used the site, it was kind of too much for a limited amount of processors to handle. So no one get their videos back. But here's our video back. It is just segmented to the part where they're drawing on a whiteboard. So clearly the model has picked up that, hey, this is the part you're asking for. So in theory, you could like upload a movie and search up like, hey, where's the action scene? And then it will like find it for you just like that. And so, yeah, this is live on videoclip.pages.dev. If it breaks, message me because it's still a little bit unstable. We're a little bit less developed than I guess our predecessor presentation, but we had a very challenging engineering task to get this to work. And so, Zhongwu, do you want to talk a little bit about future plans?
Yeah, of course. So some future plans for this project is of course monetization. Because this project could in theory be used for like large scale companies for like to take large videos and just quickly like find the best chunks for some like instances. And one other thing that we wanted to change is like the algorithm speed. So right now, I believe like I forget the exact numbers, but like each like minute of video takes like 15 like some amount of time to process, which is it's extremely slow. And as you just saw, a 10-second clip even took like 30 seconds to process. So what we're trying to do is make the algorithm faster. That way it's very scalable to larger like the movies that we described earlier. And utilizing sound. So right now from earlier, just like how Daniel mentioned, he mentioned how like it's using the video and like the image, it's using only like the frames of the video to process like the best clips. But if we utilize sound, it could give more accurate results. And also in the output, when it gives out sound, that would also be useful for users as well, which we do not have.
And yeah, so I mean, lots of room for improvement and iteration on this. This is much more M, I guess, in the MVP. But it still works and it's deployed and it's live. And so, yeah, I guess I wanted to maybe ask a few people in the group any learnings or things they think they've personally gotten out of this project. So Ping Yao, you want to talk a little bit?
For me personally, I've never worked with like it React before, and certainly like not on this scale of a project. So it was a big learning experience for me, and I really enjoyed it. It was like really fun working with people like I've never met before, because most of my projects involve people at school or people around me. So getting to know new people and working with them was along with learning a lot of things, is like I feel like I got a lot out of these 10 weeks.